So we're talking about the interference lab tonight. It involves using something like this, or this slide, which are called diffraction gratings. The property is interference, even though the slides are diffraction gratings. And we're going to be using this equation, d sine theta equals n lambda, for doing our calculations. So the way to think of a diffraction grating is if you take a Sharpie and you draw all these lines, take a picture and turn it into a slide, that's a diffraction grating. The lines block the light, but in between, the light gets through. So you have many, many beams of light, many, many sources of light getting through. If the slide says 300 lines per millimeter, remember a millimeter is a dot, that means there are like 1,000 or more lines in this little slide. Now what we're going to see with one of the, I'll use this one, is just a few beams getting through. It's not like the slide chops the light up into 1,000 pieces. There are just special angles in which you have constructive interference, where you see the beam. We have, this is straight across, this is to the right. There are others to the right that are off screen, and to the left as well. So this is how you want to think of it. If you take the slide and do it perpendicular like that, you can think of successive beams coming through different openings here. And this beam will travel farther than the next beam. If the difference in the distance, if the path difference is a multiple of the wavelength, then you're going to have constructive interference. So if d is the distance between openings, and this is theta, that's theta, the path difference is d sine of theta, here's our equation. You will have constructive interference if d sine of theta is equal to n lambda. Now, here's your physical setup. You're going to have a laser, a diffraction grating, and a screen. So you want to measure the distance from the diffraction grating, which is your source, to the screen. You want to do this distance and use trigonometry to figure out your angle. If you use the dot just to the right of the middle, here's the middle, to the right of the middle, then n will be what? So d sine of theta is equal to n lambda. Now here are some things to think about. If the openings are closer together, that is, if you have more lines per millimeter, what will the dot do? Okay? So if I go from this slide to this one here, right? The dots came closer together. That means that if d has gone up, the sine of theta has to go down. So I think here we have the distance between openings has gone down. I'm messing this up. The dots have come closer together, which means theta and sine theta are less, so d has to go up. So the spacing between the openings has increased, which means there are fewer lines per millimeter. Suppose we change the wavelength. We go from red light to green light. You remember the spectrum, Roy G. Biv. If you go from red to green, the wavelength has gone down. Okay? That would make the sine of theta go down, so green light through the same slide would be more dots closer together. Okay, I think that's it. Enjoy doing your lab.